Hi, I'm Yue Yu. I'm currently a rising junior in NYU Shanghai, majoring in mathematics. I'm doing a DERF project this summer called What Makes Internet Celebrity. My mentor is Professor Raoul Normand. This topic arouses my interest because people nowadays tend to rely heavily on social media for daily communications. There are many social media platforms: Facebook, Weixin, Instagram, Weibo, etc. The online social network makes it easier to measure the relationship between people than real-life social network. So my project focuses on the clustering of people on online social platform and what makes some of them as the internet celebrity. I choose this Zhihu as my major source of data because Zhihu not only has the following structure of users, but also has the function of Quora, and user can get likes and agrees for their answers on Zhihu. So it gives me another parameter to evaluate the user, not only depending on their following relations. In other words, the users are valued according to both their followers and the quality of their answers. Next is my theoretical basis. I based my research on graph theory and classic clustering method in machine learning. The social network graph is a directed and weighted graph constructed based on the following relations of the users and their own importance. And centrality analysis is used to analyze who is the internet celebrity in the group and what makes them the internet celebrity. For clustering method in machine learning, I mainly use spectral clustering on this huge dataset in order to see whether people with the same text will be more likely to connect to each other, simulating the fact that people with similar interests are more likely to engage with each other in real life. Next part is data acquisition. I used data crawling in Python to retrieve data from Zhihu. The library I used include Beautiful Soup, URLlib, and Selenium. The data crawling contains 3 steps. First is simulate the Zhihu login process and save the cookies. Second is using the cookies to log in the web page automatically and receive the result back from the browser. Third, I performed the data cleansing on the dataset. But because of the new published policy of Zhihu, the available data is very limited for my research. So I contacted several researchers and website maintain developer and got the database retrieved earlier from them. My dataset are distributed in several SQL files, including various user information and their following relations. In the end, we are looking at this dataset. It contains over 26,000 users and over 2 million questions and 5 million topic info. And this slide is an example of how the user information looks like after data cleansing. We could see that location, follower number, and the industry they are in are used for later analysis. This slide is an overview of the follower information. Next part is the centrality analysis. In graph theory, there are many different ways to calculate the centrality of a user. Each of them prefer different factors. The 2 centrality algorithm I mainly use is Hits algorithm and PageRank algorithm. There are both link analysis algorithm that are often used in internet-related studies. For Hits algorithm, it generates 2 values, hub value and authority value. And for hub value, certain web pages, known as hubs, served as large directories that were not actually authoritative in the information that they held, but they let the users direct to other authoritative pages. For authority value, a good authority value represented a page that was linked by many different hubs. For example, a user who is following a lot of internet celebrities will have a higher hub centrality, while a user who receives a lot of agrees and not following a lot of people will have a higher authority centrality value. For PageRank, it gives each user an initial centrality value and redistribute through the network. And it is an algorithm used by Google to rank web pages in their search engine result. In this ranking, I will mainly use PageRank centrality to decide who is our internet celebrity among the 26,000 users, and later analysis will focus on the internet celebrities and which positions they are in the clusters. We could see that the ranking in this table, they are mostly similar. But some different rankings for same users in different algorithms can show the characteristics of the user and his fans. The last theoretical part is the spectral clustering. For spectral clustering, there are mainly 3 steps. The last part is spectral clustering. For spectral clustering, it is a classic clustering method in machine learning. It generally makes use of the spectrum, which is the eigenvalues of the similarity matrix of the data, to perform dimensionality reduction before clustering in fewer dimensions. And spectral clustering mainly contains 3 steps. Step 1 is to define a similarity matrix. Each entry of this matrix should be representing the similarity between 2 different users. For my graph, I used the number of common topics minus the number of not common topics times a smoothing factor, and then divided by the number of total topics. Step 2 is to calculate Laplacian matrix of the similarity matrix and find k smallest eigenvalues and eigenvectors. Because of the property of Rayleigh quotient, it could reduce the dimension from n to k. So this greatly reduced the complexity of calculation. Step 3 is to use k-means clustering on the k-smallest eigenvectors. You may want to ask why we don't use k-means directly, because we would use k-means in the step 3, so it may sound reasonable to use k-means directly in the beginning. But the answer would be k-means clustering prefers the data which is relatively perfect in a high-dimensional sphere, and it may not be so suitable for the data in social network, which is relatively random and not in a perfect shape. So in this case, using spectral clustering may have a better clustering performance.